So good morning, friends. Welcome back to the online learning platform at Department of Civil Engineering, BMSIT and M. So, we are back for the course Municipal Wastewater Engineering. And if you recollect, in the previous session, we had understood about primary treatment. Okay. So continuing forward in today's presentation, we shall be understanding about secondary treatment. Okay. Primarily within the secondary treatment, we will be discussing about attached growth process, and this interaction will probably continue for the next 2 to 3 sessions. So in this presentation, I'll explain to you what is the significance of secondary treatment in municipal wastewater engineering, what are the different ways you can go about achieving it, and among these different ways, we shall be delving upon attached growth process and what is primarily its working principle, what are the factors which influences it, and within this attached growth processes, what are the different technologies available. Then I shall be summarizing it and listing the references for your kind perusal. Now, whenever we speak about secondary treatment, okay, the most obvious thing which comes to our mind is biological treatment. Okay, and yes, I will be continuing today's presentation in the same context. However, like a quick recap, I want you to remember, okay, please do not forget that secondary treatment is not restricted only to biological treatment. Yes, in most of the circumstances, situations, it is biological treatment which is predominant, but under specific conditions or circumstances, it is also possible that your secondary treatment can involve chemical treatment. And when I say chemical treatment, I'm delving upon the fact that you go for clariflocculation. That is, you will be adding coagulants, you'll have a rapid mix, okay, you'll have a gentle mix, and then you have a quiescent settling. However, only if the circumstances demand it, then you shall go for this. Please note, if you go for chemical treatment as a part of your secondary treatment, then you cannot continue forward with biological treatment, because the chemicals that you have used here would have destroyed all the microorganisms. Okay, with this basic fundamental concept, let us start today's session. So what is secondary treatment? Obviously, the treatment which follows, okay, or succeeds after primary treatment. And what is the objective of your secondary treatment? The objective is to remove anything which could not be removed by your primary treatment. If you recollect, okay, what did we achieve? We had achieved removal of floating matter with screens. We have achieved the removal of oil and grease, fatty acids with your skimming tank, okay, or flotation. Okay, we have also achieved the removal of non-putrescible, non-biodegradable inert materials with grit and grit chamber and detritus tank. Okay, apart from this, we had also achieved the removal of settlable solids with the help of sedimentation tank. So this is what we have achieved in preliminary and primary treatment. So whatever that could not be removed by these treatments, that is what we are focusing upon in the secondary treatment. For instance, the suspended solids, the dissolved, the colloidal soluble solids, that is the residual organics. Okay, now when we speak about this, we are basically talking about biological treatment itself. So when I say biological treatment, I'm talking about those microorganisms which are present inside your municipal sewage. And what do? These bacteria or these microorganisms, they look at this waste matter, they look at these solids, they look at these impurities inside the wastewater as the food. Okay, since it is their food, they tend to break it down, they tend to consume it. Okay, and when they do that, when they consume the impurities, they break it down and produce carbon dioxide, ammonia, methane, water, hydrogen sulfide, and yes, they also reproduce. Now, what is produced depends on the state of oxidation. For instance, if you're talking about an aerobic treatment, then probably you will have water, carbon dioxide being produced. But let us say you're talking about anaerobic treatment. absence of oxygen, then the byproducts would be ammonia, methane, hydrogen sulfide, and so forth. So in this process of biological treatment, what do you achieve? You are able to take the help of the microorganisms in breaking down the impurities, and what they do is, as they eat, they also reproduce. So more they reproduce, more the microbial cells are being produced, they tend to feed more on the incoming sewage. Okay, now what we need to understand here is secondary treatment in the form of biological treatment can be aerobic or can be anaerobic. Now, when I say anaerobic, it is in the absence of oxygen. Okay. Now, when I say aerobic, it is in the presence of oxygen. And please remember, when I say aerobic, here, not only it can be a natural system wherein we allow the air to mix in wastewater, but also we can actually supply artificially oxygen to the system. Okay. Now, what you also need to understand is, whenever we say secondary treatment, okay, we always think about concepts such as trickling filter, activated sludge process, rotating biological contactor, biotower. We always think about that. But secondary treatment, my dear friends, is not restricted just into these components. Always there is one more component associated, and that is your secondary clarifier. Okay, so in simple words, a sedimentation tank. So basically what happens is, after the treatment which happens in your trickling filter or your let us say your activated sludge process, whatever the treatment may be, okay, now the supernatant goes to your secondary clarifier and sludge formation takes place. So what you need to understand is, trickling filters or activated sludge processes, they are primarily responsible for treating the wastewater. Okay, their main focus is not the settling of sludge or removal of sludge. Yes, there would be a certain quantum of sludge which may be produced, let's say in the context of ASP, okay, let's say in the aeration tank itself, but it is always delved upon to remove it, because your trickling filters and your aeration tanks are not meant for settling of the solids. Okay, if that happens, then it would disturb or impair the functioning of your trickling filter, or it would destroy or disturb the functioning of your aeration tank. Okay, so please remember one thing: in secondary treatment, in biological treatment, trickling filters, RBC, biotower, they do not serve the function of allowing the sludge to settle. Okay, this settlement of the sludge, okay, removal of sludge, all happens in the secondary clarifier, all happens in the sedimentation tank, which succeeds this treatment unit. Okay, sometimes it is possible that a portion of the sludge is returned. Okay, and that usually happens when it comes to aerobic processes. In anaerobic processes, a return of sludge would not enhance the efficiency. Okay, now unlike any other sludges which is formed, let us say your primary sedimentation tank, unlike that, the sludge which is formed here would have more microorganisms. So you can say, call it as a biological sludge. Okay, and this is primarily mixed with the primary sludge. Okay, probably we'll understand this concept in the next class when we speak about activated sludge process. Okay, so with this basic understanding, basic information, let's proceed forward. So there are two ways in which your biological treatment takes place. One is your attached growth process, okay, which you see below, and the other is your suspended growth process. Now, irrespective of attached or suspended, we need to realize that microorganisms, when they naturally feed upon the impurities, that kind of, it's the rate of progression is kind of slow. So probably we can also enhance the rate of reaction. That is when we create conditions such as supplying more oxygen, or introducing more microorganisms or a seed. Okay, now the examples for a high rate biological process would be activated sludge process, trickling filter, biofilter, okay, oxidation ditches, and rotating biological contactor. Sometimes it's also observed that these treatment techniques can be employed in series. Okay, that is, after your aerobic treatment, you can go for anaerobic treatment. But yes, this again depends on your design criteria, depends on the land availability, depends upon the economy. Now, what we need to also understand as a part of secondary treatment introduction is, when you say microorganisms are being employed to treat the wastewater, okay, not only the fact remains that they are aerobic and they're anaerobic, but also how do they do it? Okay, are they fixed to a medium or are they suspended in the wastewater? Okay, so at the same time, we need to understand the relevance of each of these techniques. All of these techniques have their own merits and demerits. Let's have a quick look at activated sludge process, which I shall be delving in the next class. So here you can see that the microorganisms are actually suspended in the wastewater. Okay, so you can see the bacteria which has been mentioned here. So in this reactor, the microorganisms are actually suspended. Also, you can see that there is no formation or deposition of sludge. Okay, for removal of sludge, you have a secondary clarifier. Okay, now this is how an activated sludge process or the system would look like in reality. Okay, that's the aeration tank for you. Okay, now, so friends, let us start today's session. Let us start today's lesson on attached growth process. I request you to look at this image. I'll give you probably a couple of seconds. Okay, look at this image. Let's follow along with me as I read out. Okay, this is the filter media. Some surfaces which are being provided for the microorganisms to stick. Okay, this is your anaerobic zone, where there is no oxygen available. So all the microorganisms which are present here are anaerobes. Okay, now this is your aerobic zone, that is, there is sufficient oxygen present. Okay, all the aerobic activity generally takes place in this zone. Okay, now let's look at some other terminologies. Okay, we have wastewater which is flowing like this. When the wastewater is flowing, there is air which enters. Okay, now this is the direction with which the wastewater comes out. Okay, now this is your liquid film. Okay, basically this is where aerobic activity takes place, and this is roughly 0.1 to 0.2 millimeters thick. Okay, this is your slime layer. Okay, now let's also try to look at these words. Okay, we have organic matter, we have dissolved oxygen, we have nutrients, we have carbon dioxide, we have end products. Look at the direction of the arrows. Okay, you find certain arrows which are going towards the slime layer, that is air, organic matter, dissolved oxygen, nutrients. Now what are the things which are coming out of the slime layer? Carbon dioxide and the end products. So friends, let me try to explain this to you. I do have a video to show you, but let me try to explain the core, the context of attached growth process. Okay, in your attached growth process, that is, I am delving upon the working mechanism. Okay, here basically what happens is we have microorganisms. All right, now these microorganisms are attached to an inert medium. All right, then these inert mediums, probably it could be rocks or any corrugated surfaces, it could be ceramics, or it could be designed plastic materials. Now this is purely a fixed film process, and how efficient your process is, it would depend on how much of surface area is available. Okay, due to the inert materials. So basically what is happening here? Okay, what is basically happening here is, if I imagine that we have this as a filter medium, so what happens is when the wastewater is initially flowing. Okay friends, I want you to observe carefully. Look at the movement of my cursor. Okay, let us say you have the filter media here. Okay, let's say some rocks, some slags, okay, ceramics. Then the wastewater starts flowing like this. As the wastewater starts flowing like this, okay, so the microorganisms come in contact with these surfaces and they get opportunity to stick to them. Okay, so the microorganisms are getting stuck slowly to these surfaces. Over a period of time, the wastewater continues to flow and the microorganisms continue to stick to these surfaces, and slowly you find that the expanse has happened. Okay, so finally over a period of time, what do you observe? You observe that the wastewater is flowing here. which means, this much of portion, okay, once upon a time it was a, a bare surface. This much of portion has already been occupied by the microorganisms, now also called as the biological slime layer. So now what exactly is happening when your wastewater is flowing on top of it? When the wastewater is flowing on top of these microbial uh, components, what exactly happens? What basically happens is there is diffusion of oxygen, that is dissolved oxygen, and nutrients, okay, that is your organic matter and probably anything else which serves as a nutrient for the microorganisms. Okay, so that would get diffused into this layer. Okay, so all your organic matter, DO and nutrients, they get diffused into this. So when they get diffused into this slime layer, okay, when they get diffused into this aerobic zone, when they get diffused into this anaerobic zone, what is happening? There are bacteria present here, there are bacteria present here. Okay, they start breaking down these organic matters. So when the bacteria present here breaks down the organic matter, okay, it produces carbon dioxide. Okay, let us say the bacteria present here breaks down the organic matter, it would produce methane, hydrogen sulfide, ammonia, okay, and so forth. So eventually it's as simple as that. The organic matter, the impurities are getting diffused into this with oxygen, okay, into these two layers, and from here what happens? They are broken down and end products are released. Please remember, most of the treatment here is anaerobic. Okay, only a very small fraction of the treatment is aerobic in nature. Yes, the rate of decrease of the nutrients, that is how much the nutrients have got decreased inside the control mass. Okay, now we need to realize that, okay, it entirely depends on the diffusion aspect itself. It's as simple as this. For instance, you have nutrients entering here. So what is the rate at which nutrients are entering? If the nutrients which have already entered here, if they have been utilized by the microbes, then there will be more nutrients entering inside. Okay, so in simple words, the rate of decrease of nutrients inside the control mass can occur by diffusion of nutrients out of control mass and also by decay. Okay, please remember one critical factor: the consumption of the substrate, that is organic matter, or the food, okay, the impurities, the solids. So the consumption of your substrate does not take place in the liquid film, it does not take place here, rather it is taking place in the microbial film. In other words, the decomposition, the decay happens in the microbial film, it is not happening here. My dear friends, I want you to remember this. Okay, bacterial degradation is not taking place in this zone, it is taking place in this zone, which is anaerobic zone plus aerobic zone. That is where microorganisms are present. Okay, please note the diffusion of nutrients in the liquid mass towards the microbial film, that is the diffusion of nutrients from here into this. Okay, it will continue, it will continue until it is getting utilized by the microorganisms. So in simple words, I can say that the rate of diffusion is directly proportional to the microbial activity. That is, when the microbes are more active, when the microbes are breaking down the organic matter, they invariably utilize nutrients and oxygen. Okay, so if the microbial activity is very high, the rate of diffusion of nutrients into the film also will be very high. Okay, now please understand, if I want to improve the efficiency of this process, how can I go ahead? If I want to improve the efficiency of this principle, it all depends on how your your inert medium is kept, how you have kept your sorry, how you have kept your surfaces which are meant, okay, which are meant for the microbes to stick. Okay, now let's say you're talking about trickling filters, then they are randomly placed, so probably efficiency may come down. But let's say you are placing all the surfaces in mediums in a structured manner, in a well planned manner, let's say like a bio tower, then the efficiency will automatically improve. Okay, so let's look at a small video to improve your understanding of this process. Please note the working principle of attached growth process is very important. Your understanding of this principle is very critical to understand how trickling filter works, how rotating biological contactor works, how biotowers work. Okay, let's see a small video from YouTube. So these are the microorganisms which are actually present in your wastewater. Let's look at this once again. So, you would find millions and millions of diverse microorganisms which is inside your wastewater. And it is these microorganisms which are actually, breaking down the waste matter. Okay, now they may be aerobic in nature, they may be anaerobic in nature. Okay, now let's try to understand further. Now, look at this. So this is your slimy layer. Okay, this is where, let's say this blue line, what you see here, I hope all of you can follow me. This blue line, what you see here is your surface. Okay, the inert media, maybe a rock, maybe a plastic. Okay, now to this, the microorganisms have got attached. All right, so this portion you see, which is dark in nature, is probably your, the anaerobic zone. Okay, or probably something is going to happen there, which we will see shortly in the video. Probably these are the aged or old microorganisms which are continuing towards the end of their lifespan. Probably these microorganisms are new, fresh, active, energetic, and young. So what is happening is the wastewater is coming like this, and all your impurities, your nutrients and oxygen is getting diffused into that. See, they're getting diffused into this layer. Okay, so when they are getting diffused into the layer, they start breaking them down. So you can see dissolved oxygen is entering, you got impurities entering. Okay, so this is the diffusion aspect that I was trying to explain to you. Now, over a period of time, what happens? Let's look at this. Over a period of time, okay, this width will enhance. In simple words, over a period of time, these microorganisms, okay, they will not be able to access the food. They will not be able to access nutrients. They will not be able to access dissolved oxygen. Why? Because there is a additional layer of microorganisms who are more active, more energetic, more younger, more fresh and new, which is overlying that. Okay, so when they start feeding on the waste impurities, okay, these microorganisms will eventually die. They will eventually perish. Now, what will happen? It is not these microorganisms which were stuck to the surface. It was this microorganism which was stuck to the surface. So when they die, automatically this will happen. Okay, they fall off. They fall off from the surfaces. This is called sloughing. And now the process continues. Again, when the wastewater is flowing, the new microorganisms will get attached to these surfaces. And the cycle continues. See, again, there is a formation. So, what was I trying to tell you? Okay, sloughing is a phenomenon. Sloughing is an attribute wherein these microorganisms which are present very close to these surfaces, since they lack access to food, since they do not have access to nutrients, whether they are aerobic or anaerobic, okay, when they are unable to feed, multiply, reproduce, they eventually die. When they die, okay, this entire portion will fall off. This entire portion will come off. This is called sloughing. And again, for this entire system to re-establish, the wastewater which is coming has to again encompass or enable the microorganisms to get stuck to it. So it's like a cyclic process over a period of time. Okay, the surfaces develop, the microbial film develops. After a certain period of time, the entire film washes away. Okay, now of course there are various factors which decides it, such as your organic loading rate and your hydraulic loading rate. We'll look into that in the next few slides. Okay, now there are different technologies which are employed, which employ rather the concept of attached growth process. The most important and probably the most famous is trickling filter. A trickling filter is there further in your curriculum, so hence I'll be delving it in detail in your subsequent classes. But this is how a trickling filter looks like. Okay, and as I would rather say, trickling filter, if you observe, you would find that most of the structure is underground. So this portion what you're looking at, this blue color, okay, is the rotating arms. This blue color is your rotating arms. All right, now this portion what you see here is entire below the ground. Okay, now this portion what you see here, that is where the water is sprinkled. Okay, the water is being sprinkled or sprayed onto this surface. Okay, and then eventually the water which is wastewater, so eventually the wastewater which is coming down is basically trickling. Please remember, whenever I employ the word water, it is because the logic remains same. Your wastewater is still 99.9% water and 0.1% the solids or impurities. Okay, now the only thing you need to understand in trickling filter for this class is, all the materials, all the packing materials, all the inert materials such as rocks, slags, stones, ceramics and plastics, they are randomly kept inside this tank or cylinder or unit, okay, which is basically underground. Okay, so therefore its efficiency is also impacted. As you can see, this is actually exposed to the atmosphere. So we shall understand in detail its construction and working, okay, in the subsequent class. Now let's continue further, keeping the scope of biotower to be covered today. Now, biotower is very similar to your trickling filter, but what is the difference? In a biotower, the entire structure is outside the ground. Okay, your trickling filter, most of the portion was below the ground. It was underground. Okay, now biotower is also having the same principles such as trickling filter. The probably the difference is wherein you randomly place all the surfaces or materials or plastics. Okay, in a trickling filter, in biotower it is not like that. In a biotower it is properly, neatly, well organized and structurally constructed and arranged. Okay, and the objective is to improve the efficiency of distribution of wastewater, to improve the efficiency of treatment of the wastewater. Okay, basically what happens in biotower is you actually employ oxidation of organic wastes. Okay, that is, aerobic bacteria are more active in breaking down the wastewater, but in your trickling filter it was mostly the anaerobic bacteria. Okay, now what happens here is the wastewater is actually pumped to the top of the tower. In your trickling filter also same thing happens. In your trickling filter also the wastewater is pumped to the top of the tower. Okay, and then from the top of the tower the wastewater comes down. It is distributed on the top surface. Even in trickling filter same thing happens. The wastewater is pumped to the top, and then from the rotating arms it is sprayed or sprinkled, or rather uniformly distributed over the entire top surface. Same thing happens in a biotower also. Okay, now what could be probably the advantages? While your trickling filters are exposed to the atmosphere, it comes with its own issues such as fly nuisance, okay, and odor problem. But your biotowers, as long as it is enclosed and it's covered, these issues would not arise. Okay, now mostly the application of biotower is not restricted just to your municipal wastewater. Even industries, okay, even your food processing industries, or when it comes to your tanneries and it's not tanneries, sorry, your distilleries and so forth, they also would employ that. Now I have a small video to show you from YouTube which shows the actual working of a biotower. Now, the wastewater has been. Now, please remember, they say it's a trickling filter. Yeah, you may call it a trickling filter because the principle remains same, wherein the wastewater is actually trickling down. But please note, this is not a trickling filter. This is a biotower.
Pumped to the trickling filters, the mechanical and physical process of primary treatment are concluded. The next step is biological treatment, which is known as the secondary treatment.
So you can see here how the wastewater is being distributed, how the wastewater is being sprayed or sprinkled over the top surface. Okay, while in a trickling filter you would see stones and slags and plastics. Here you see a proper structure.
Treatment process. The wastewater that is pumped from the primary effluent wet well to the top of the two trickling filters is spread evenly across the surface of the filters through revolving pipes known as distribution arms. These arms have holes known as ports.
Trickling filter also same thing happens. There are these four rotating arms which rotate at a very slow pace throughout the entire circumference. Okay, same working principle, same operation.
The trickling filters are 86 feet in diameter and about 46 feet tall. You can see these structures as you drive along Route 1 between Cook's Corner.
If you see this, you can see well structured surface. That would not be the case in case of a trickling filter.
And Main Street. The biological treatment process happens when microbes consume organic matter and wastewater and convert it to carbon dioxide, water, and energy for their own growth and reproduction.
I'll replay once again this video to you, but just see here how the components have been constructed, okay, and intentionally constructed so that the efficiency of your treatment increases. Of course, there would be a variation from model to model, manufacturer to manufacturer with certain patentable secrecies. Now let's see once again.
Now that the wastewater has been pumped to the trickling filters, the mechanical and physical process of primary treatment are concluded. The next step is biological treatment, which is known as the secondary treatment process. The wastewater that is pumped from the primary effluent wet well to the top of the two trickling filters is spread evenly across the surface of the filters through revolving pipes known as distribution arms. These arms have holes known as ports. The trickling filters are 86 feet in diameter and about 46 feet tall. You can see these structures as you drive along Route 1 between Cook's Corner and Main Street. The biological treatment process happens when microbes consume organic matter and wastewater and convert it to carbon dioxide, water, and energy for their own growth and reproduction. The microbes grow on a plastic cross-flow type media, which looks like a honeycomb. The media in each filter is 22 feet deep. The cross-flow design enables more biological treatment to be accomplished in a smaller space because of the increased surface area. The surface area in each filter is 3,830,000 square feet, the equivalent of 80 football fields. More area means more room for microbes to grow. The slimy growth on the trickling filter media is called a zooglial mass. It is where the microbes such as nematodes, stalked ciliates, and rotifers live and break down the organic chemical bonds in the waste. When the biological treatment in the trickling filters is complete, the microbes have eaten their fill. They are fat, dumb, and happy. The microbes will die from lack of oxygen. They fall off of the trickling filter media and exit the bottom of the filter as a solid called humus, also known as secondary sludge.
So I sincerely hope that that video has improved your understanding of a biotower, also called as a biofilter. Okay, now let's move to another technology which is called as rotating biological contactor. Okay, now as you can see here, while in your biotower it was a stationary or a fixed unit, but here it's a mobile unit. Okay, so when I say rotating biological contactor, I am talking about discs, cylindrical discs, wherein you saw that in biotower it was horizontal. It was about 10 meters high, in fact, but here you can see there, sorry, vertical. I'm sorry for the mistake. While you saw that in your biotowers and trickling filters, the system was vertical in nature. Okay, here it is rather horizontal in nature. Okay, and now what basically happens, this is your entire system of your rotating biological contactor. So those structures what you saw in the previous video, okay, those structures are actually inside this. So it is this structure which is going to help the microorganisms to get attached to it. Okay, so basically what happens here, okay, they are kept on ground, they kept on a rectangular channel, okay, where the wastewater is going to flow. The wastewater is basically going to flow into these. When the wastewater is going to flow into these actually slowly move, they actually slowly rotate. Okay, please note these discs are actually fixed films, okay, and they rotate at a very slow rpm. Please also remember that they're not completely immersed or submerged in the wastewater, they're only partially submerged. As you can see here, there's a one portion of the rbc which is exposed to the air. So basically this is an aerobic process, okay, and since it is constantly rotating, okay, since it's constantly rotating, it is predominantly a aerobic process itself. Yeah, of course, after you do this, you need to do disinfection, because this technology does not remove bacteria or virus. See, if you go back to your trickling filter or your bio tower, okay, you had rotifers and other organisms which would feed on the bacteria and viruses, but here it does not happen. And not only that, your rbc is not successful in removing phosphorus or nitrogen or any other non-biodegradable impurities. Okay, let's try to have a better view of this. So these are your surfaces, okay, on which the microorganisms get attached when they get immersed into the wastewater. So how would the cycle be? Okay, so if this is your rbc, this is the aerobic portion. So when the wastewater is moving like this, it starts revolving. Okay, so when it starts rotating. So when the rotation takes place, one portion of the disk is immersed in the wastewater, the other portion of the disk is exposed to the atmosphere. So in one rotation, okay, half portion comes in contact with wastewater, microorganisms get attached. In the second part of it, they get exposed to the atmosphere, wherein they start taking in oxygen. Okay, now look at the structure of how a rbc would be. Okay, now I hope this has helped or enhanced your understanding of how a rbc functions. Okay, so primarily, if you talk about modern technologies, if you talk about modern technologies in secondary treatment, in attached growth process, in your biological treatment, you always delve upon trickling filters, okay, biotowers and rbc. But much before this, much before this, we also had other technologies which was being employed. Okay, technologies such as intermittent filters and contact beds. Okay, now what you're looking at is basically an intermittent filter. Now I would rather say that these were the early stages or early development of your sewage treatment units. Okay, in fact, since you have learned slow sand filters in your water supply, in very simple way I can tell you that the construction of this is very similar to your slow sand filters. Okay, and exactly like slow sand filters, they also require a large area. Okay, so basically an intermittent sand filter, it would employ layers of sands. Okay, however, in the event that if the soil itself is sandy, then you would not require that, because we know very well that sandy sand have very good percolation abilities. Okay, now how does it work? Basically, again, we have the sewage which is actually applied evenly onto the top. Okay, so this is your intermittent filter, so the sewage is actually evenly applied on the surface of this. And then obviously, due to your mechanical straining, and then your biological action, that is bacterial action, okay, the degradation of the wastewater takes place. If you remember, in your water supply also, the filtration was based on mechanical straining and bacterial action. Now what is the problem with these kind of filters? Of course, these filters are no more in application. They have a lot of disadvantages, such as they require large area, and yes, they cannot treat large quantity of sewage coming from a municipality. And obviously the rate of loading is very less. If you tend to have a very high rate of loading, whether it is hydraulic loading or organic loading, then it will lead to issues such as clogging and bad odor and fly nuisance and so forth. Okay, however, if you go for the concept of less organic loading rate, less hydraulic loading rate. Okay, if you consider that, if your requirement is lesser, if your demand is lesser, then the advantages are that its operation is very simple. Okay, and obviously you don't need large heads. Okay, as well, there is no secondary sludge which is being produced in this. Okay, but yes, having said this, having said that, there is minimal maintenance, but yet there is a regular maintenance which needs to be undertaken. Okay, otherwise it will lead to clogging of the filter. And yes, obviously when you go for this kind of technology, it's better you have a buffer of a land area around this place. Okay, but yes, the bottom line is, intermittent filters are obsolete or outdated and no more in practice. Okay, let's go to one other technology such as intermittent filter, that is contact beds. In fact, your contact beds were once upon a time very popular in ancient time, and in fact its construction is very similar to your intermittent sand filters. Okay, now the only difference is the filter media. Okay, in case of your a contact bed, the filter media is broken stone or brick ballast. But if you go to your intermittent filter, it was sand, right? It was sand. It was different levels of sand, layers of sand. But when it comes to your contact bed, it is broken stones. Okay, now you're basically talking about a filter media whose where the depth is about 90 to 150 centimeters. Okay, now again the operation is similar. You have the filter media, okay, now which is made up of bricks and ballast. Okay, again the sewage is applied uniformly over the media. Now when the sewage is applied uniformly over the media, there is a microbial film which develops on the top surface. Okay, now the wastewater would be broken down by the top surface in aerobic fashion, while the wastewater which is going down, okay, would be broken down in an anaerobic fashion. Okay, now when you compare to the other technologies such as biotower or trickling filter where you have to pump, okay, here there is a very less operating head required. But now the interest with respect to contact bed is outdated. It's only a historical interest that once upon a time in your ancient ages this technology existed. And I would rather be proud to say that if you're talking about modern technology such as trickling filter or biotowers, it is probably an advancement, and it's probably something which has come from influence or appreciation of a contact bed. Okay, now before I end this presentation, I would like to tell you that when it comes to your operation of your contact bed, there are 4 stages. Okay, one is filling. Now in this, what happens? The sewage is applied on the surface, okay, as quickly as possible by a dosing siphon. Okay, now this process of filling takes about 1 hour. The second stage is what we call as contact. Okay, now in this you stop the dosing operation, you stop application of sewage. All right, and you give it about 1 hour time for the sewage to come in contact with the microorganisms. Okay, now the third stage is emptying. In this stage, what happens? The contact beds are slowly emptied or drained out. Okay, and you do it slowly so that the broken down soluble contents of sewage is also not washed out with the sewage. The last stage is called resting. That is, after you empty, the contact bed is allowed to remain at rest for at least 6 hours. So what you're doing, you're allowing atmospheric air to enter, you're allowing oxygen to enter. Okay, so this is as simple as when it comes to the construction and working of a contact bed. I would also try to remind you that contact bed and intermittent sand filters, they are not part of your syllabus, but the objective of covering this is so that you appreciate what technologies existed before. All right, okay. Now, having said all this, there are various factors which influences the efficiency of your attached growth process, such as how much of wastewater are you applying. Okay, that when you apply more than what the microbes can feed on, it would result in the disruption of the system. Okay, what is your hydraulic loading rate? Are you applying it slowly, gently, or are you applying it very hard, very fast? Okay, because if you apply it in a very rapid fashion, then you're not allowing the microbes to get attached to surfaces. Okay, or also it may result in sloughing action. Okay, now what is the rate at which your oxygen is diffusing or the nutrients are diffusing? What kind of impurities are you talking about? Because here prominently it has to be biodegradable impurities. What is the temperature of the wastewater? Let me tell you, okay, these technologies that we have spoken here, they can very well work in India, because it's a warm country, it's a hot country, but cold countries such as Russia and Siberia, they cannot employ the technology of trickling filter. Okay, because microorganisms are not very active in uh, colder regimes. All right, let's see a small video that can enhance your understanding as I finish this presentation.
Biological processes in wastewater.
This is kind of this video will be like a recap for you. Okay, so please observe and listen carefully.
Treatment can be classified into two main categories: suspended growth and attached growth / biofilm processes. In suspended growth processes, the microorganisms responsible for wastewater treatment are maintained in liquid suspension by appropriate mixing and aeration. The most common suspended growth process is activated sludge. Instead, in the attached growth process, the microorganisms are attached to an insert packing material such as rock, gravel, redwood, and especially a wide range of plastic-filled media packings. Plastic-filled media blocks consist of corrugated sheets usually made of PVC or polypropylene material. Either by vacuum or thermoforming, the corrugation is pressed into a flat plastic sheet. In detail, you can see a corrugation structure within the main corrugation. On the one hand, this provides more surface area for the attached biofilm growth, but on the other hand, the corrugation structure functions like stiffeners, giving the flat sheet more resistance to compression buckling. Details in the corrugation shape differ from manufacturer to manufacturer, and they are often a patented secret. When the corrugation is formed into flat sheets, their material thickness is changed as well. However, the material thickness change is not random. Instead, known weak points are reinforced with more material, whereas other areas are thinned out to save material costs. Also, the overall sheet thickness of plastic-filled media packings can be varied by using different flat sheets to optimize stability and material usage, depending on the application. A good example for different film media thicknesses are the layers within a trickling filter. Please click on the above link for more information. The corrugated sheets are either welded or glued together at dedicated connection points to build plastic-filled media blocks. Polypropylene is very difficult to glue and is therefore always thoroughly welded, whereas PVC can be glued together easily. Depending on the application and degree of wastewater pollution, several different plastic-filled media designs are available. In general, they are divided into two categories: cross-flow and vertical flow. Within the two categories, plastic-filled media blocks differ by their channel sizing. Smaller channels mean more surface area, which equals more attached microorganisms and more treatment capacity. But at the same time, the risk of filled media channel clogging increases as smaller the channels are. Typically, the surface area of plastic-filled media blocks is between 30 and 70 square foot per cubic foot, 100 to 240 square meter per cubic meter. Cross-flow fill media blocks are used where good air and water mixing is required. A typical application is a trickling filter. The sprayed wastewater from a rotary distributor must moisten the plastic fill media surface area evenly throughout the whole filter. At the same time, natural draft from the trickling filter bottom must reach all plastic fill media blocks. Finally, vertical flow fill media blocks are used where a particular flow direction must be maintained. A typical application is a submerged fixed bed reactor. Produced bubbles from aerators underneath the fixed bed reactor rise vertically upwards. To minimize power costs and optimize contact time with the attached biofilm, the bubbles must stay inside the fixed bed reactor until they reach the water surface.
So that was a quick recap for you that with respect to the concept we have understood today. So what is that we have learned today? We understood the significance of secondary treatment. We understood the logic of biological treatment. We have realized, how the waste impurities are being broken down, what is being produced. Okay, today we also had dealt upon, the two types, aerobic and anaerobic. Okay, and also we had a glimpse of contact bed, intermittent sand filters, rotating biological contactors, and biotowers. Okay, so these are the references I've gone through. I would request you to go through this and enhance your understanding of today's session. So in the next class, we shall be delving into the details of construction, working, okay, advantages and disadvantages of trickling filter. Please remember, trickling filter is a secondary treatment. Trickling filter is an attached growth process. Trickling filter is a biological treatment. So I'm done with the presentation, friends. I thank you once again for your kind attention. Thank you.